series using summation notation. So we need to remember what summation notation is, and that is the sigma symbol. So we know we're going to have the sigma summation notation. We can use any variable we want. Let's say we choose to work with I on this one. So we're going to start with I equals 1, and the I equals 1 is going to give us the first term, and then the 2 is going to give us the second term, the third term. So we need to know, how many terms are we going to end up having? And we're going from 25 and stopping at 250 and counting by 25s. We could sit there and count and say, okay, well, 25, 50, 75, 100, 125. And then in the end, you would see that we have 10 terms. So that 10 is going to go up here. And now it's a matter of figuring out the pattern that's happening with our numbers so we can write that as a rule. And so what are we doing? To get from 25 to 50, 50 to 75, we're noticing that we are increasing by 25. And so anytime we're finding that common difference, I know that I'm just going to go ahead and put that with my variable, 25 times I. And now let's test it just to make sure it works. If you start by plugging in a 1, so 25 times 1, does that give us the first term, which it does? All right, now 25 times 2, which is 50. Is that the next term? It is. 25 times 3, 75. So far it's giving us all the terms. If you want to make sure you're ending with the same term, now remember, you start by plugging in a 1, end by plugging in this 10 up here. So 25 times 10 is 250. And is that the last term of our series? Which it is. So now I know that this is the summation notation that represents this series. All right, this next example has fractions, which can be kind of scary looking until we separate it a little bit in our minds with how we look at this. First, we know we're going to have our summation notation, the sigma. And again, you can use any variable this time. I'll go ahead and use 1. We'll start with n equals 1. And we want to know how many terms do we have. And this is where we pay attention to this dot, dot, dot. And what that means is that this is going to continue forever. When things continue forever in math, it's going to continue on for infinity. That's what we say. So now let's look at the fractions and see if we can determine any sort of pattern that's happening. And what I like to look at with fractions is, do I see anything happening with the numerators, and do I see anything happening with the denominators? Sometimes that's where we see the pattern, and then we can write our rule as a fraction. So we notice that the numerators are increasing by 1 and starting with a 1. And we know the first number we have to plug in to our rule is going to be a 1. So I'm going to start with an n on top. Now when we plug in a 1, n equals 1 will give us this 1. When we plug in a 2, we'll get that 2 on top. When we plug a 3, we'll get the 3. So far I think that's going to work out. And now we just have to figure out for the denominators. Denominators are increasing by 1 as well, but if you notice it doesn't start with a 1, it starts with a 2. So if we plug in a 1, how can we get to that 2? And so we might say, well, if you plug in a 1 and you add 1 to it, you're going to get that 2. So we could say n plus 1. And so let's just check to make sure that that works. Our first term, plug in a 1 over 1 plus 1, which is 1 over 2. That worked to give us the first term.